Welcome to Presidium, London, our innovation hub here in London, Ontario. We're going to take a few minutes and we're going to talk about process and some parts that are produced through our RevoTherm material systems. So the first thing we're going to look at, we have a nice selection of different parts out, different processes, some reinforced, some non-reinforced. We're going to start down at this end of the table. We're going to look at some of the highlights of some of the stuff we've worked on over time. So this part here is a light bezel from our articulating dump truck. As you can see, it's 3 light fixtures. This part was originally designed to be closed molded in an RTM process with reinforcement, with a glass reinforcement. It was designed to be 4 millimeters thick, very rigid. So when we had this project handed off to us, we built the tool to their spec, to their 4 millimeter spec. This part is unreinforced. This is our RT material, unreinforced. So once this was done, we looked at this and said, we could do better. What can we do? Well, let's reduce some of the costing of the part. So we took that part, and I looked at, okay, what can I do to make it stronger but lighter? So we introduced, and this is one of the nice key features of our material, is the ability to tool in ribbing. Okay? So what I've done is we've tooled in ribs to give some extra strength. I've also removed 1 millimeter out of the overall thickness. So it'd be safe to say about 20% reduction of materials. We still end up with a very stiff, strong part, but at a much lighter, much cheaper cost. The other great thing about our material, and you'll see this coming up in other parts, is we can put ribs, details in without causing undue print through in areas. So you won't see the rib lines. Another look at these ribs. This is the car seat we manufactured or did a tool for. It never had ribs on the back. So this tool, we designed it to put extra ribbing in. We were able to reduce the thickness. This was originally a rotomolded part. So we took that rotomolded part, made a single tool, and gave a rib back structure to give it that built-in strength out of our material. Here's a piece that's very common. It's been shown quite a few times in some of our videos and literature and media. We call this our paint tray. It's just a simple design to show off some of the highlights we can do. If you can kind of see, it's a little tough to see, you'll see it has our RevoTherm, has our Presidium P, and that was tooled right into the tool itself. So every part comes out with this much detail. Great thing about our resin, it grabs lots of detail. What I really like to show you is on the inside. This is where the magic happens, typically on the B side of a part. We have the ability to go thick and thin. So you'll see here, this part is tooled at 4 millimeters. We drop down to about 1.5 mils here. But we also have raised embosses and a rib in the middle of this. This emboss is 4 millimeters, or 5 millimeters thick on a 4 millimeter part. So 9 millimeters in total. And if I turn this around, you will see that there is no read-through, no print from those very high solid resin areas. The other great thing when I have this part in hand about our material, since it is so strong by itself, resin-rich corners, if you do happen to get any, are not a problem. Not like typical RTM where you're dealing with polyesters or vinyl-based resins where you get that they're not as strong. We can either, in some cases, reduce the amount of glass that is required in the part, or continue the amount of glass, and if someone has a little bit of layup issue, never a problem, because this is strong and it won't chip away on you. What we're going next is just a little subsection, cut out of one of these. This part has been gel coated with a polyester red gel. The part itself, just like this, the difference is it's glass loaded. You can see the fibers. It's pigmented black though, which gives us a nice color between our black and our red on the surface. Again, this is a polyester gel coat, sprayed in mold coating. It could be a paint as well. We get incredible adhesion since we have a urethane backbone system. Kind of looking at the back, we have 2 parts, both manufactured different ways, but all closed molded. So the very far back part, the same as these ones here, is like an RTM process. So you have a rigid top mold, rigid bottom mold, thermally managed. This part here is a process we are getting deeper into now, is light RTM. So now we have that same ability, great strength, but now we only have to heat one side of the tool. So your bottom tool will be thermally managed. Your top tool, like a typical light RTM, is not thermally managed, and it's light, so 1 to 2 people can carry around. This top of this tool, I can carry around myself. It's that light. Moving along, this is a great example of 2 parts, well, actually, same part, one being neat material, unreinforced. The other one being glass loaded, reinforced. So the great thing is the material can be used either or depending on your required strength you require. This tool was a great tool to the feature that I was able to tool this side by side, right? So there was 2 parts in one mold, either both reinforced or both neat. They get tooled like this in a mold, and you're able to produce 2 parts at once. Moving along, now we're going to start getting into some more exotic or heavier reinforcements. What we have here was a project that asked us to do for a manhole cover. They were looking at replacing typical steel heavy manhole covers, something much lighter, and something, to be honest, that people aren't stealing for scrap metal. We were asked to build a manhole cover that would take 40,000 pound load in the center, representing a transport tire sitting here. This is a 5/8 thick cover we made. We tested this to 60,000 pounds. So beyond what was required, to give you an idea of the layup in here, this here is the fiber stack up for that part. It is a mixture of CFM and UDs. The whole thing is CFMs and UDs. CFM is used as a flow medium, strength pulling from the UDs. The UDs are orientated like a spoked hub, so when all the force is delivered here, it spreads it out over the entire surface. As you can see, heavy and thick laminates are not a problem for our material to wet out. Especially even UDs, which are commonly not that easiest to wet out. So as we slide over, we're moving into some other exotic materials. This is 2 layers of 11-ounce carbon fiber twill. You can see it's about 1.5 mils approximately thick. Great strength of our material. Great surface quality. What I have behind here is a part we produced. This here is 4 parts in one. It actually gets cut into 4 separate pieces. But what we've done with this is they needed the carbon fiber look on the one side, but to help reduce the cost. So this again is 11-ounce twill carbon, and on the back is a 10-ounce twill glass. So what we've done is we've reduced the cost of the part by only giving the carbon where it required the appearance. You get the stiffness from the carbon, but now I'm getting the strength as well from the glass on the back. The other thing is, I like to point out for people, is carbon fiber, when it fractures, when it fails, you get those sharp shards. If you put glass on the back or have glass integrity in with it, now if it fails, it won't shard. It will break, but you don't get those razor blades that you do from carbon fiber. Okay? Another great thing is we've had no problem with interlaminate shear between the 2 dissimilar materials. The one behind it is just typical 2 layers of glass. Moving on, we have a nice sub-panel, a little sample of aramid material, or no, it's Kevlar, but aramid. This panel is roughly 3 millimeters thick at 40% glass loading of aramid. You can see we don't have a problem wetting out an aramid material, not full of porosity. So again, the material, the resin itself, lends itself to very many different substrates, many different reinforcements. You can also encapsulate. There's not a problem with our material. Here is a very thick panel core, foam core. It has 2 layers of a quad axle glass encapsulated around it. So again, if you're looking at some form of paneling, floor subsections, wall subsections can be done. We encapsulate it. It's not a problem with our material.